Today I'm going to talk about storage in Kubernetes. When we met last year in the basement of Galvanize in San Francisco with the community, Kubernetes community, they asked for topics that we wanted to discuss. And a lot of us from Red Hat said storage, and people kind of scratched their head and said, storage? Who cares about storage? Well, once you get past getting Kubernetes to work when, the time when minions existed, storage wasn't very relevant. But as Kubernetes matures, storage becomes very relevant. So storage in Kube, why would you want to have storage in Kube? There are many reasons. First of all, containers are ephemeral. When you shut your laptop lid or you close out that, it's gone. Poof. So for that reason alone, if you want to maintain any data that your application generated, you're going to want storage to back that. Multiple pods that you're running may want to share data to accomplish a specific task. Therefore, persistent data needs to back that in order for them to share the data. You'd like to be able to read from an existing storage source. Kubernetes is not just for greenfield installations. Kube goes into places where storage already exists. They may have huge data centers that have Gluster, NFS, or Ceph that they want to read data from. For instance, data analytics is a perfect example of that. And the last one is pod rescheduling. You might want to move your pod from, from production to test or vice versa. And if your data is stored locally, you're going to lose it. So I want to add a fifth one to this after Maciej's talk earlier, right before lunch. If you want to have jobs that run in parallel, persistent storage is also another reason that you'd want to be able to use that. So Kubernetes volumes. It's kind of a nebulous term. They're not all persistent. The persistence is actually determined by the volume plugins. And depending on the plugin that you decide to use, it basically is roughly mapped to a directory for that storage type. I've put an example here of what my mount looks like on my, it's an OpenShift cluster. I created this NFS mount, and here's actually the name of my persistent volume that I created, and that's where I could go do an ls in that directory to see my files. It's kind of hidden, but if you're running pure Kube, you can simply just go into the pods directory, look through this crazy generated string, volumes, and then you'll be able to see the name of what you're looking for there. So what are the supported volume plugins? Today, I've categorized these into temporary. Some people may argue that EmptyDERP is actually somewhat persistent because it is being written somewhere, but to me, persistence means when that pod is done executing that the data still lives somewhere, and with EmptyDERP, that's not the case. Local, which I also kind of refer to sometimes as pseudo-persistent, is host path, and we'll discuss that in the next 3 slides a little more. And then these volume plugins we would refer to network attached storage. There's a physical storage somewhere that exists that data is being written to. And you could create your own volume plugin if you wanted to. So EmptyDERP. I recently moved into a new house, and through the hassle of packing, you kind of realize you have different types of boxes that you put things in. And EmptyDERP is kind of your trash box. It's your roommate's things that never paid rent that you're not planning on keeping, so you throw it all into that box and you leave it there. When a container is gone, so is your information. All containers in that pod can read and write to the same location, so you're not worried about collisions and data being overwritten. And by default, EmptyDERP uses whatever storage is being backed on that node. So if you're on a node that has SSD, then it's going to get written there. But it also can be configured to use memory. If you do this, it's going to go against your memory allocated for your container. This isn't a fun way to get more memory. It will affect your application if you don't account for that. So why would you ever use this? You'd want to use this in test, possibly, just to test that your application can write out some data. Maybe you've written a new application for logging and you just want to make sure that it actually works. That's a good use case. This is not ever meant for production. So, sorry again, Kelsey, here's some YAML, but it's necessary. So within the pod definition, you have this volume stanza label. You simply give it a name. In this case, we use Nginx because what else do you use? And I've called it empty to indicate I'm using EmptyDER, and then just use the EmptyDER label. So host path. Host path, in terms of moving, is your prized possession of comic books that's in your parents' attic. It's real, it's tangible, but if your parents move and that box is still in the attic, it stays in the attic. And the same thing is going to happen with your pod. If you use host path and local storage associated with it, if your pod suddenly gets rescheduled to a different node, your data is somewhere else. So why would you ever want to use this? This is important for applications where locality and performance are a concern, where you don't want to have to be attaching to a network disk and have that latency. Today, it is not supported in a multi-node cluster. That's coming later in the last slide, I think, that we'll talk about. In addition, if you tried to use it in a way, in a multi-node cluster, your path could become invalidated. Because host path is not protected by namespace, you could have a user in a completely different namespace that happens to be deploying the same database as you, using the same opt/data path. You could both be overwriting your configs. So do not use it in a multi-node cluster, only use it as local storage on a one-node instance. Some more YAML. So again, we have the same volumes label. We give it the name so we all know what we're doing. And then we put in the host path to indicate the host path, and then we choose the path that we want it to go. This is different than EmptyDER, which generates the path for you. So persistent storage, really what you're here to learn about. Data persistence, when using persistent volumes and persistent volume claims, is no longer tied to the pod. When your pod goes away, it doesn't matter. The data still exists somewhere out there. You can read and write from it. And it really decouples the creation of the storage from its consumption. So Kubernetes provides a layer of abstraction through the API objects of persistent volumes and persistent volume claims. And the idea of persistent storage within Kubernetes was based on cattle storage. So you've probably heard this in several of the talks. So you have your pets, your cat or your dog, and then you have your cattle. And I had a hard time reconciling my brain around cattle storage for a long time because I live in Montana, where industry is driven by beef. And when people told me it was pets versus cattle, and that cattle didn't matter, and you just got rid of them and got more, it just didn't make sense. But what makes sense to me is that cattle, for the most part, are fairly homogeneous. If you're going to have a steak, cattle A versus cattle B, they're both pretty tasty. But they're anonymous when you're talking about storage. So regardless of which one you get, it's both going to satisfy your needs. And so pet storage has a strong identity, which today, Pet said, as you've heard in many other presentations, is what's lacking in Kubernetes. It serves a very specific function, and you repair it rather than replace it. And you care where it's located. You care that you're going to need that data locality, or you're going to need to be in the East data center. With cattle storage, it's qualified by a number rather than a name. You replace it when you don't need it. And generally, it's potentially the same. So you might have a bunch of Ceph RBDs or NFS, but they can be mixed. You might also have dairy cows and beef cows, but for the most part, you don't care as a user. And you don't care what node that the pod lands on in reference to the cattle storage. You're not worried about locality. So there are other storage characterizations when we talk about storage in Kubernetes. So file on block really is just a raw volume of storage. Within Kubernetes, it's generally formatted as ext4 or XFS, and it's owned by a single owner. And this is important, and we'll get to this later in terms of security. Shared file is the most simple to use. When you ls and look at a file, it's the same on the client. as it is on the system that it exists, and access is controlled via supplemental groups, which are just your normal Linux file system groups. So in terms of namespaces, as I mentioned earlier, how do persistent volumes and persistent volume claims talk to each other? So up here, we have a purple box, which is a persistent volume of block storage. Only one pod can make a claim against that storage at one time. That is the significant difference between the file on block and the shared storage. Whereas the persistent volume on the right would be shared storage. Let's say it's NFS. And I use NFS as an example because it's kind of the gateway drug for storage. Everyone's used NFS regardless of what they've done, so it's the easiest to onboard when we're talking about storage. And so what happens is an administrator can create this persistent volume, and then depending if the pods are configured correctly for security, different people can then claim against that storage, and they don't have to be within the same namespace. However, because they aren't in the same namespace, I cannot see that Bob over here is claiming against the storage that Sally is as well. Only an administrator would be able to see the sharing options underneath the covers. So a persistent volume. As I mentioned, the volume outlives the pod's lifecycle. It's provisioned by the administrator. In Kubernetes, sometimes you play both roles. In a more enterprise level Kubernetes installation, generally your storage administrator and the developer are not the same people. It actually ties to a physical piece of network storage, and the API object, as I mentioned, or plugin, as they're referred to, determines the storage type, and it's a global resource. So if we look at the spec for the persistent volume, we have the kind, persistent volume, the capacity, and the access mode. I've bolded these because these are very important when it comes to actually claiming this storage. And then if you've noticed on my previous slide where I had cattle and pet, I had a little kitty cat and a cow. Well, I don't think you can call persistent volume true cattle storage. It's more what I call a caw, which is a cat and a cow together, because you do care when you create, as the administrator, the persistent volume. You have to actually specify what plugin, what type of storage you're connecting to. Therefore, it's not completely anonymous. I'm having to put a path. I'm having to put an IP of where the server or a name. So it kind of, it's a caw. We'll go with that. So now that the administrator has gone out, created the storage, as a user, I want to claim against it. In this case, it truly is cattle storage. The user is wanting to make a request for storage. And today, I can make that request for storage and it can go unfulfilled forever. And the claims only exist within that pod's namespace, and there's a one-to-one relationship. So my claim to the persistent volume is only going to be a singleton. I cannot take a claim and claim to several different volumes at a time. So here's the persistent volume claim. It's pretty simple. I give it a name. I give it these access modes I mentioned in the previous slide, the read write once, and the storage that I'm looking for. And what's going to happen on the back end is going to do a best match against those two labels. Now, this is very important and very confusing when you start using storage. These labels are not enforced. So, you know, you can go over that 8 gigs. It's just matching that persistent volume that happens to match that. Also, the read write once, it's not really true. So these labels are simply used as matching. They're not used to enforce anything in terms of the storage characteristic on the back end. Oh, and the other important thing is I've named it NFS claim up here, and that's probably a disservice because I'm not necessarily going to get NFS. I could get Ceph. It could match these two labels as well. So as a user, you have to remember the persistent volume claim is cattle storage. You're making a request for storage and it's being fulfilled, but you don't get to specify how it's being fulfilled on the back end. It's very, very important that you understand that. And that these labels are just labels. They aren't actually doing anything. And so once you do create the persistent volume claim, you have to put it within your pod. So the name that you gave within the claim, you then also put within this volume section, persistent volume claim. These names have to match. It is case sensitive. And, whoops, pardon me. Google was doing a weird thing with the spacing here, so don't try to copy and paste. It should line up correctly, just like all YAML. So what if you do care? What if it's important to you as a developer, the application that you're using, you want to go to a specific NFS server and put your data in a specific place? We just skip it all. If we can't utilize the cattle storage, then we also have Kubernetes provides a flexibility within the plugins to just specify within your pod definition underneath the volumes, the NFS plugin directly the path that you want to go to in the server. And this becomes very useful where you care where your data lands. There's a third option, which was released in Cube 1.1, is an experimental feature, which is called dynamic provisioning. Right now, we only have 3 dynamic provisioners that are available, Cinder, AWS, EBS, and GCE persistent disk. And what this allows is within your claim, and this is a CAW type of storage because you actually care where you're getting it, you can specify using this annotation the storage plugin that you want to use. And what happens, provided you have your credentials set up for the cloud provider before you do this, it will go off and create a disk of 3 gigs, read write once in the back end, and automatically create that persistent volume for you. So as far as the storage lifecycle goes, we provision the storage. And this can be done manually through your YAML, or you can use dynamic provisioning, which is more what we're moving towards. Once it's been provisioned, that storage becomes available. A pod creates the claim request against it. It goes into a pending state. And I've put up here failure. In terms of user experience and going through this is the most common area that you're going to see a failure. And you're going to get some pretty horrific errors back. It's going to tell you the volume can't mount. No reason why, it just can't. Or you'll get the famous crashback loop. And so my team at Red Hat is responsible for helping make this better in terms of your volume can't mount because your endpoints don't exist. Your volume can't mount because you don't have the right permissions. These little things make all the difference in the world when trying to actually use this. So if it worked and the volume mounts, then we go into a bound state and we can use it. But once the claim is deleted, the storage is released, the persistent volume and persistent volume claim are no longer tied, and the persistent volume goes into a retained state. This is the default policy. And I forgot to mention, you can specify a policy to recycle when you set up the persistent volume. We are going to be deprecating this. Today, only host path and NFS support recycling. And the reason why is we had to write scrubbers in order to really scrub the data for it to be reused. And we found that once we implemented dynamic provisioning, that it was much easier to just get rid of the volume and then create a new one if that's what we needed, rather than worry about possibly having someone else's data being shared with someone else because of the recycle policy. So it's supported now, but over the next year, that function will become deprecated. The other way that we can unbind the storage is we can provision it. Same way, it goes into a pending state, same failures. We can delete the pod. Therefore, the PV and the PVC goes back into this released state, but we can immediately reclaim that by making another pod request. So this is just showing you that within the persistent volume claim architecture, that it's not tied to the pod. So long as you don't delete that bind between them, you can re-request with that pod against that. And I've indicated here that when you do this, there are today some timing race conditions in which storage seems to be in a vague state of what's going on, and so just be aware of that. Storage is still pretty immature, and we're working through those, but this would also be, as a user, another place that you would see failures within the system. So once you actually get it working, if you played with storage in 1.1 and looked at like the NFS example within Kubernetes, it basically told you, export your NFS export open to the world 777, and are we really going to do that in production? Absolutely not. We need to be able to run storage the way it's intended to. Storage is a critical resource to many people, and we have to be able to make it secure. So today within 1.2 Cube, there is a pod security policy. It has the different types of, for instance, SELinux, FS group, and supplemental groups, but they aren't enforced today. Somewhat like the labels of access modes and size aren't enforced, neither are these values. And there's no admission controller. So it's not worried about how containers are being ran or who they're being run as or what the security exists on the storage. OpenShift, which is a PaaS on top of Kubernetes, provides what's called a security context constraint, and I probably could have done an hour talk just on it. But it provides a set of conditions in which a pod can run, and the first one being a privileged container, to be able to properly wrap the storage and allow a container to not run as privileged or to allow it to run as privileged without setting everything wide open. You can OpenShift out of the box does not allow you to run host path. So you can set up a security constraint for a specific pod to allow it to use host path. You can extrapolate the SELinux labels and apply them to your block storage. Same with the UID. You might have a Postgres database that has to run as user ID 27 or something crazy. You can now put that in your security constraint instead of having to go in the Docker file and rewrite what it's running as. You can allocate the FS group that owns that volume for block storage, and then you can also take the supplemental groups or Linux groups that your NFS share is using, put those in the pod to be ran as such. And the nice thing about it is the SECs are defined by the namespace and can be restricted to specific users. So you can create, you can either use the 6 that are defaulted by OpenShift, or you can create a custom one depending on your user's needs. So supplemental groups. It's important to note that you have to pay attention to how your Linux group is defined on your NFS server in order for this to work. So if I set this wide open to the world, it's going to work regardless, and I don't have to go to the trouble to put it in my pod, but that's not realistically how we're going to do it in the real world. So within our pod definition, we're adding in this security context label and then the supplemental groups, and you'll notice that the supplemental groups is bracketed. This allows us to create a range in which the different groups can exist within the pod, because within shared storage, you can have many groups own different directories within that share. FS groups is like supplemental groups, but it's more. It does what we call a takeover in storage, in that the value assigned within your security context is now going to own that storage, and any subsequent files that are created on that storage will now be owned by this group ID. So again, it's not bracketed because it's a single owner situation in which fencing is in place for block storage to prevent any other users from using it. And the supported list of volumes that use it are AWS, OpenStack Cinder, GCE, iSCSI, which I haven't seen iSCSI on anyone else's volume slides, EmptyDERP, Ceph RBD, and Get Repo. And then lastly, SELinux is also just supported by the block storage devices. And this allows you to take and label your storage with your SELinux options. Here we've used some of the common, alphanumeric things, but in a real world scenario, you might want to use SELinux to relabel the volume as finance, something like that. So, upcoming features. So, we're going to expand dynamic provisioning. That should land in 1.3 Cube. And that's more of a CA type storage in that you're going to be requesting, as we have dynamic provisioned different plugins that will be supported. Storage service classes. This is an admin function, so then an admin can create different levels of storage. We commonly use the bronze, silver, and gold levels of storage. What this does is this prevents people from requesting very specific things about their storage, but puts it in more of a tangible thing, like my application is not very important, bronze storage is going to work for me. Or my application needs the fastest disks out there and I'm going to need gold. What it also will allow us to do is allow administrators to give different namespaces or projects access to these different levels of storage. And in addition, the same with dynamic provisioning. Not what you want to prevent is someone to dynamically provision, 100 extra large disks from AWS. You'll be broke by noon. So, the workings around it to prevent something from like that happening. Storage selectors will be great from a developer standpoint because you'll be able to utilize cattle storage, but in a way that makes sense. So you will request, I need, GCE persistent disk and I need it in East. So, you'll be able to associate a label that the administrator has created on the storage and try to search for the storage in that sense. Pet set is creating a strong identity for storage and the associated things that have to happen to make that possible. Pet set touches many things within Kubernetes, scheduling, affinity. So it used to be called nominal services and has been around for almost 2 years now. If you want some really good late night reading, start with the nominal services and move your way up to pet set. It is a complicated and important function that I'm grateful the community is very conscientious about how important it is to have pet set, but how important it is not to rush pet set, out into the community too fast. Because what we don't want is customers to lose confidence in storage. We want them to be able to depend on the storage and know that it's there. And PetSet will allow, these cases where you want to do scale out applications. Containerized mount that Wamin Chen sitting here in the front helped push through Docker that allows a mount to happen on a node that may not have the drivers for it. Improved error hints and statuses. I'm actually one of those strange engineers that cares how this gets consumed. And, my job at Red Hat is to make sure that, it is a pleasant user experience. And we're not talking from a UI perspective, that people are actually able to debug it and understand it and contribute to it. So that's coming soon. And then better documentation for troubleshooting examples. And examples are very important. I mean, you can provide a nice, on-ramp to storage, or you can provide, a rickety rope bridge over a raging river, and I think it's better to provide that on-ramp that's solid. If, we help people become part of the community and understand storage better, then it will be easier for them to contribute back. If we have a lot of problem even getting started, people just give up. They put NFS open to the world, or they don't use it at all. They decide to use EmptyDERP and not worry about it. So please contribute, get involved in the community. It's a fairly small community right now, and it could use all of your input. All right, questions? Are we doing the mic, Kelsey?
So is EmptyDER the recommended way to deal with TempFS within a container?
Is what?
Using EmptyDER. Is that the recommended way to deal with TempFS?
Yeah, I would say, for sure.
Okay.
Yep.
Okay. And the second thing is actually, if I want to get involved in the pet set discussions, a couple of people have solicited this. Where do I go?
The best places to start is to comment on the design of that PR in terms of getting involved in that discussion. I would think that's the best way, all the mailing lists. But the place to start most generally within the Kubernetes community is to comment on the design proposal PR. Don't comment on the old one, nominal services. I'm not sure it's being watched.
Approach this from hey, I want to run Oracle in a container. Are there any gotchas from the storage perspective that you've ran into or have seen?
No, I mean, the one that's important is the local storage and it not being appropriate for, a multi-node cluster, I would say. But I wouldn't say that, you have to choose your storage appropriately as you would your application running outside a containerized environment. You're going to want to take the same considerations when moving to Kubernetes, right? So you're going to want to pick the storage that fits, what your application's actually going to need. I guess one of the features I left off is, hyperconvergence of storage is one of the things we're working on. So we'll have containerized Gluster and containerized Ceph, which will also help speed up the onboarding when you can just simply deploy a container that will have your storage within it. So that's another feature that's coming down the pike that people can look forward to. But in general, I think, storage is one of those things that isn't new and it has existed prior to this. So people have to think about, how their application existed before containers did and take those same considerations when they're looking at storage in Kubernetes.
And I guess a quick follow-up, what about access to the raw block devices? So I've seen some databases that just want the raw block device and they'll deal with it. Is there any support for that, or will PetSec give you raw access to the device?
That's going to be a proposal.
Yeah.
Okay, so it's part of the proposal.
Yeah.
Okay.
Hi. On your dynamic provisioning, have you got the major vendors lined up like NetApp, Nimble, etc.?
I couldn't hear the last part of that. Can you? Yeah. Steve Watt here, who is lead architect at Red Hat, he's definitely had the discussions there around with NetApp partnering.
So it's an open community, right? So we have a proposal, and then basically the way dynamic provisioning works is that you'd write a provisioner. So you can come in right now and write your own provisioner. So it's fully open to anybody, and then there's sort of two interesting dimensions around that. There's entry provisioners, which means that you'd write your provisioner, contribute it to Kubernetes, and then it would ship with Kubernetes, so anybody who gets it would have it. And then there's out-of-tree provisioners, which are a little further behind because we want to make sure that an out-of-tree provisioners being, Kubernetes is built and then shipped, and then you could write your own provisioner and sort of configure Kubernetes to use it, right, regardless of what it is. And so the out-of-tree we're not pursuing as aggressively because we sort of want the dynamic provisioning's new. We want it to sort of stabilize before we start exposing an interface to have like a bunch of provisioners running around in the wild, where we want to have it stabilized so we can get it working consistently before other people start building to that interface.
Okay, so for the persistent volume claim, you said that that's not enforcing anything like the amount of storage that you get. Is there anything that's being done to actually look at how you can enforce that?
We're definitely looking at enforcing those labels. Both the access modes, the read-write once, and the capacity. Capacity and quotas are somewhat being addressed, but not all the way. So we have some initial work out there for quotas, which would address the capacity to make sure it doesn't go over, but it's still within the works. It'd probably be in 1.3.
Okay, great, thanks.
Mm-hmm.
Yeah, it's kind of related to that. I was wondering about the volume claims. If they exceed the persistent volumes, it's like what actually happens. I mean, presumably something breaks, but
Nothing happens today. So, you're going to attach to that shared storage based on that capacity. Given in that label, it's going to match you to that share, but you can actually go outside the bounds of that.
Okay,
today.
so would the pattern be to allocate persistent storage for particular like clusters or something, or allocate a big block and then kind of hope nothing overwrites each other?
Yeah. We've kind of gone back and forth with the design. We've definitely have customers requests that I'd love to create a provisioner that does this, and this is part of the dynamic provisioning that, is an NFS share of 100 gigabytes, and then each person that claims against that is carving out a small piece of that, and that quota is held true. So that's one of the things that we're considering doing.
But at the moment, it kind of relies on the operator to take care of that bit. So would a safer pattern at the moment be to allocate persistent storage volumes for specific things so that you can make sure that they're not over claiming on them?
Or make the chunks smaller,
Right.
actually on the physical disk. We do have quotas with an OpenShift, but it's just allowing the number of claims that can be made. Now that doesn't prevent me from creating a giant disk on AWS, right? My one claim can be huge. So there is a lot of work that has to happen in that area to make it truly enterprise ready, so you don't have storage concerns. The storage administrators are definitely worried about managing that piece of it, and we take that into consideration.
Thank you.
Good question.
Right, what Erin's saying is it's not automated within Kube, right, or OpenShift, but you can go to the NFS share. And on the XFS file system or ext4 file system, the directory that you're exporting as an NFS share, that you're making a persistent volume, you can set an XFS quota on that, right? So you can do it manually. You just can't automate it, right? And if
you don't, they're not tied. That's what I was saying. You would you would handle that on the actual storage, which is what I said. And then, the claim is going to be secondary. If your claim even happens to be bigger than that, you just won't be able to go over. You'll get an error that you can't write to that volume anymore.
And I think it's safe to say that this discussion comes up in general with the Kubernetes API. And this is why I like to talk about Kubernetes as a framework, and things like OpenShift add a lot of value on top, because the policies is what most people are describing here. How do you prevent X from happening? And I think Kubernetes is more of a configuration. It captures what you want. So it assumes the storage administrator's desire is to present this particular thing. So I think when you start to get into the dynamic world, where you enable that, and I think this is where mission controllers, where you see someone attempting to do these things, you're like, I don't know if you can actually dynamically claim that much storage. So I think that's kind of the give and take on the Kubernetes APIs. It has to be flexible enough to allow OpenShift to do their own policy, you to build tools on top, and how much does that need to flow towards the bottom?
Right, and it has to be open enough that people can write proprietary plugins if they want to, if they have this whiz-bang storage type that they want to include and they don't want to contribute back. We have to always keep that in mind, that we don't create it so narrowly that it can't be expanded, but then it does push a lot of the responsibility onto the storage administrator. So we do have the conversations of what are the key things important to storage, quota, security, that all people who do storage will care about. And those things are coming, but we're making sure we're really coming out of the gate with a solid foundation, that we're not trying to get too feature happy and put a bunch of features that don't have a lot of meat behind them.
That's all for the questions. Let's give a big round of applause for Erin.